In this section, we're going to develop really, I think, an underappreciated skill because it's not one that you'll use a great deal when you're doing the actual subnetting, which is coming up, I promise. You'll use the calculations for number of valid hosts and number of valid subnets more often than this skill. But I tell you, this comes up every once in a while as a bit of a lifesaver because when it comes to the IP addresses and which subnet they're on, of course, in many networks, you can just look at the address and tell. If I give you the IP address 10.1.1.10 and give you a /8 mask or a /16 mask or a /24 mask, you're going to be able to say immediately, well, if it's a /24 mask, it's on the 10.1.1.0/24 subnet, and that's that. I would not ask you to write that out. You wouldn't have to. But sometimes you need to write it out to see which subnet an IP address is on because every once in a while communication problems come up because you think the host and the device is trying to communicate with are on the same subnet and they're not. And maybe routing isn't making that communication possible. You got to have them on the same subnet in some situations. So let's look at an address here in a moment. I want to tell you first up though, I'm actually going to show you 3 ways to do this. And they are not 3 wildly different ways. The first time we're going to do a walkthrough. It's a longer method, and then I'm going to show you how to shorten that a little bit, and then I'm going to show you how to really get to the nitty-gritty very quickly and perform this determination really in less than a minute, probably even less than that once you get some practice in. I do have an answer for you on the board for people who are saying, why don't we just do the short ways first? Truly, though, I want you to see exactly what's going on. I don't even like to call these shortcuts because it sounds like you're doing something you're not supposed to be doing. The faster methods are not shortcuts, but they are slight variations on the longer method, and we are now going to get to that. I'm going to look at a subnet or an IP address with the 1017.214/18, and we need to determine what subnet this address is on. It's a 3-step process, and this is great because this is the long version. And the third one, hey, that's pretty easy, right? Actually, they're all pretty easy because first off, we just need to convert the IP address to a binary string. We need to then add up the network and subnet bits only from that address, leaving the host bits out. And frankly, then you're done. It's time to enjoy the sweet taste of victory because you have nailed the question. So here I have written out the address we were given and the mask we were given. And all you have to do is add up the bits in the binary string that are covered, if you will, by the subnet mask. And that goes how far? That goes through the 18th bit. So all you're doing is adding up the numbers in 1017.214, but you're only adding the first 18 because that's how long the mask is. And you could look at that right here and tell immediately, okay, I know that's 1017.00 because the only bits that we're looking at are all the bits in the first octet, all the bits in the second octet, and the first 2 bits in the third octet. Now, watch this on your exam because I'm just saying that if I were writing the exam question and I asked you which subnet was the correct one, I might put 1017.00 in and not put a mask in. That would be incorrect. You have to give the subnet mask along with the subnet itself, because if you just say 1017.00, you're not really saying anything. You're not really answering the question. Also, nothing tricky here. We know this, but in any multiple choice questions, that kind of thing, practice exam, job interview, real exam, I don't care. Make sure you cover yourself with the 2 acceptable ways that can be used to express the answer to this question, or really any of this form question, because they might have the mask in dotted decimal, they might have the mask in prefix notation, and those rotten sons of guns might actually have it both ways. So got to be careful with that, got to watch that. So if this is the long method, what's the shorter method? Well, you don't have to convert the entire IP address to find out the subnet. We did it there, but we're not going to do it here. All you have to do is do the decimal to binary conversion until you reach the number of bits indicated by the subnet mask. Now, in this question, it's a /27, so it's a pretty long mask. We're not saving a ton of time, but if it were a /11, we'd save a lot of conversion time. Just given the question, what subnet contains the IP address 217.17.23.200/27? The answer is on the next screen, so if you want to work through this, please pause the video, and here we go. All you got to do is convert the first 27 bits of that address to binary, and you have your answer. Then you just got to convert it back to dotted decimal, include the mask, and you are done. So we see the string here, and when you add those back up, the answer is 217, 17, 23, 192, and you can express the mask as either /27 or 255, 255, 255, 224. And just by saying that, you can see why we say /27 a lot in meetings. Now, if you're like me, you're looking at that and you're thinking, well, that's fine that I only have to do 27 bits, but why am I even bothering to convert the first 3 octets when I know they're going to be the same? Well, here is the super accelerated method for taking care of this question type. If you really want to speed things up, which I know you do, I'm all about saving time on exam day as well, and you're comfortable with the fundamentals, which I know you are, use this method. Just convert the octet where the mask ends. And that makes more sense when you see it. I'm sure I heard some light bulbs go on. It's like, hey, I do just have to do that one. So we're going to see it in action with this question. Determining the subnet that contains the address 47.54.129 height/14. And it did sound like cadence, didn't it? So here we go. That mask ends 6 bits into the second octet. So those bits are all you need to convert the first 6 bits of the second octet, because here's the rule for your other octets. The octets in front of the octet where the mask ends, they remain the same. The octets in the back, we know those are going to be zeros. So all we have to do is convert 54, and we just need the first 6 bits of that, and we add them up and we're done. So here it is, 54 equals in binary 001, 101, and another bit or 2 might be set, but we don't care because we're Xing those out. We only need the first 6 bits. So what do we have there? We have 128 at 0, 64 at 0. We have 32 and 16 set to 1, so that's 48. And then we've got 4 more. There the 4-bit is set, and then we don't care. So the result is 47.52.00/14 or 47.52.00/255.252.00. Again, only use that method when you're comfortable with it, but I'm sure you will be quickly, because if you look at the previous question with a /27, we just took that and we know that the mask ends in the 4th octet. So we know the first 3 octets are all going to stay the same, because again, all octets in front of the one where the mask ends stay the same. All octets behind the one where the mask ends are going to be zeros. This one doesn't have any set to 0 because it's a /27, ends in the 4th octet. So all you would have had to do here is take that 4th number of 200, start converting it, and then when you're done after 3 bits, you're done, because that is your 25th, 26th, and 27th bit. So again, use the method you're comfortable with. I have found that if you write a few of them out like I did here, and then you start using this method, and then you start using the final method where you're only converting 1 octet, it becomes much easier for you. But you want to be comfortable with the longer one before you skip to the shorter one. Coming up next, we are going to determine a subnet's broadcast address and a range of valid addresses at the same time. And that is coming up next.